Hi guys, my name is Srijan. Welcome to my YouTube channel. Today I'm going to be doing something amazing. So today I'm going to be teaching you guys about Matter.js. See ya. So guys, Matter.js, if you didn't know, is a physics engine. And a physics engine is a type of environment where you can have physical properties in your gaming animation. It's really fun. You can do a lot more with it, and I'll do something amazing with it and show you guys. See ya.
So now we are going to be discussing the main components of Matter.js. So you can download the files respectively for Matter.js from github.com or any other site where it's available. So first we include the three main components here, and these two I'll come to in a little bit. So this does is it creates the engine with the Newtonian properties, and over here what it does is it creates the world in which you can append all those Newtonian properties, or you can append the engine. Bodies helps create the properties, and thus they can be added onto the world. Like I said, I'll come to these two in a bit. Now we want to create a ground, so we create this variable, and then I create two bodies here. I define them or declare them, and here I create the engine and the world. So in function setup, I do the main setup where I create the screen. I create the engine, I connect this word to the engine, I create two boxes which I'll come to in a little bit, and then what I have to do is run the engine by putting engine.run, the variable which the engine is created. And then as I said, I'll come to this part, excuse me. And here in the function draw, which is the main iteration, what I do is I put a background, I update it, and then we display the objects. So for most of the things, I'm going to be using the object oriented programming method, meaning everything is stored in the form of a class. Thus I have this HTML file that's present here to make the change to connect everything, as this all is supposed to be run at once. So I created a class called blocks, and what I do is, like, in the constructor I give 4 properties, in which, because the bodies function or bodies rectangle bodies or shape function takes these 4 parameters and additional options as well, such as a JSON, in which it can take mass, we can give it 1, friction can be 0.2 or 0.1, and you can give density and other properties too, is static, restitution, and a lot more. So then what we have to do is we have to append it to the main world. So we have stored the world in the variable world, and then you have to give this dot body, and thus I create two properties to hold these two values. And the function display, I use push and pop because we are only using this for one variable, which is this dot body in this very case. I translate the coordinates to this dot body dot position dot x, this dot body dot position dot y, and then I set the rectangular mode to center, and then I draw the rect respectively, and then I pop it. And now I'll show you the result. So now we need to use the web server Chrome to select the file, and we have to run it by the generated link. This is the main result, as you can see here. So now I'm going to be talking about the mouse constraint. So first I'm going to talk to you about these two, as I said in the beginning, which is where I define constants to matter.mouse and matter.mouse constraint. So in the function setup, what we do is we have to define the mouse. So let mouse, or let's say let canvas mouse equal matter dot our mouse, since it's already declared, mouse dot create canvas dot elt. Since that part is done, let's move on to part B, options equal mouse is canvas mouse, And now since that part is done, let's move to the other part where you have to use the M constraint and equate it to the dot create engine options. Now we have to append this to the world because it's a really important thing needed in the Matter.js, unlike the canvas mouse. But because the canvas mouse is indirectly needed, while the M constraint is directly needed. So let's just do that really quick. And we have to put it as world, M constraint. Now we have to keep track of whether it's being detected or not. So the way we do that is we write an if condition, if M constraint the body, and if that's the case, let M be equal to M constraint dot mass dot position. Let the bodies present be equal to M constraint, the mouse constraint, dot body dot position. Now let the other variable, which is the offset, be equal to the M constraint dot body dot constraint. So what this does, it keeps track of the offset, which is either point A or point B. Point B refers to the value on the body, and point A refers to another quantity. So now, if that's mainly the case, you want to draw the line. So we can do line. We can do it from m dot x comma m dot y all the way up till bodies present dot x plus offset dot x comma bodies present dot y plus offset dot y. Now let's see the result. So this is the result. As you can see, this pink is creating a constraint between the mouse and the body, and thus it's drawing the line. It's just a little bit difficult to see, but it is drawing a line, and it is really accurate. And as you can see, it does have physical properties. So the main reason I open the console is because I can do the debugging part. So now I'm going to be talking to you guys about basic constraints. So basic constraint helps to make limitations between one body and another. So let's see what we can do. So let me just create the constraint constant called constraint, and let me just equate it to matter.constraint. So since that part is done, let's just create a variable called constraint as a global reference. And now we can do two things actually. We can either create a constraint between two bodies, or we can create a constraint between a body and a specific point. And when you ever give a point reference, you don't need to add position, and you need to give it in the form of a JSON. So let me just go and type constraint is equal to constraint dot create, and if you give the options, so since there are two, let me just take this s out. Let option equal to the JSON, in which, so now what I'll be doing is I'll be creating a constraint between two bodies. So you need to give body A, which is the first body. Let's say it's box 1 dot body B is box 2 dot body. Now we can give additional things such as the stiffness and length. So the stiffness can be 0.1 and length can be about 2 pixels. Okay, so since part A is done, part B will be done right now, which is I append it to the word using the same logic. Now let me just go and show you the result. So this is the main result. As you can see here, these two are constrained, and also I have the mouse constraint also written the code, and as you can see, when I move one body, the other constrained body is also moving. Same thing if I move the smaller one as well. And yes, now I'm going to show you with points. So now I'm going to show you the same thing, but instead of using bodies, I'm going to be using points. So whenever you give a point, you need to give it in a reference which is different. And because instead of, if you want the first thing to be a point, then you put point B, point A, excuse me, and you have to give it in the form of a JSON, in which X is, let's say, the middle of the screen, so it is 200, and Y is also 200. And now if you want to do it for the second body, you have to just do the same thing but vice versa, meaning instead of changing body A, you can change instead of changing body A to point B, you should change body B to point B. Now let's see the result. So now I'm going to be showing you guys the result. So let me just yes, so this is the result. It's constraining this thing to the very center of the screen, just the way I wanted it to. And now I'll show you something else. So with help of Matter.js, I was able to create this video game, which is my own recreation of Angry Birds. As you can see, there are physical properties that are also being given here. And I have also used the constraints here. I have used various shapes here, but for these I used images instead. And that's it for today.